Assalamualaikum and good morning everyone. My name is Zulhaziq and today I will be explaining my code which focuses on two important data structures, which is array list and linked list. But before we dive into the code, let's first understand what these two are all about. So, let's start with array list. An array list is basically like a dynamic version of an array. Unlike a regular array that has a fixed size, an array list can grow or shrink depending on how much data you put in or take out. To declare an array list, you just need to specify the type you're storing using a wrapper class like integer, string, and etc. Like for my case, I'm gonna store the string into my variable, which is wordAL, and we can give it a name, and you can start adding values right away. As shown in the visual, this is how it looks when we add elements into an array list. We added A, B, and C. When we print them out, we get exactly what we expect, which is A, B, and C in order. Now, let's try adding two more lines of code using set method and add methods and see what changes. The set method is used to replace the value at a specific index. For example, if you set index 1 to D, the B will be replaced by D. Meanwhile, the add method inserts a new element at a specific position. When you do this, it shifts the existing element to the right to make room for the new value. Next up, let's talk about linked list. A linked list is also a dynamic data structure, but it works differently. Instead of using a single block of memory like an array, it is made out of nodes. Each node holds a value and a reference to the next node. To declare a linked list is pretty much the same as how you declare an array list. The way we add and print values is also similar. If you look at the diagram, you can see how it works. Node A points to node B and B points to node C, just like a chain. But here is something different. When you call something like get method at index 1, Java doesn't immediately jump to node B. Instead, it starts from the beginning, which is node A, and goes through each node one by one until it reaches the second node. That is why accessing by index in the linked list takes more time because it has to traverse the list. Now, let's see what happens when we add two more lines. From the updated diagram, you can see that the node that used to hold B is now updated to hold D. And we also added another node, E, at index 2. So now, D will be pointing to E and E will be pointing to C, which means the structure shifts as we insert new nodes. Based on everything we've gone through, you can already see that linked list is not the most efficient when it comes to searching or accessing by index. So what makes it different from array list and when should we use each? Let's start with performance. Array list is better when you access or search for elements often. You can just grab the value directly using the index. Linked list, on the other hand, is more efficient when you're inserting or deleting elements frequently, especially in the middle or start of the list. That's because this updates a few pointers instead of shifting everything like array list does. Next, about how they are built, which is implementation. Array list is backed by an array that can grow or shrink as needed, while linked list is built using nodes that each hold data and a link to the next node. Lastly, when should you use each in your program? In my opinion, go for array list if you need fast access and mostly add or remove things at the end. But if you're constantly adding or removing elements anywhere in the list, like in the middle or beginning, then linked list is the better choice. Before we go to the main function, let's take a look at the array list class. There we have constructor here, default constructor and normal constructor, and we have a setter method as well. We can insert and insert front and add value at a specified index, and we have the set data as well, setter method, and we have getter method, which is all of this until public object get, and below here we have all the processes method that will be used in the main function. Next, let's take a look at the node. We have a default constructor, we have a normal constructor, and we have a setter, getter, and toString method. As for linked list, we have the constructor here, and we have all the processes and the setter and the method right here that will be used in the main function soon. And last two is the empty list abstraction and the array list abstraction. As you can see, here is my class for tasks where I store all the attributes, and here's the set constructor and setter method, getter method, and the processor method for convert the string to local date, and here's the toString. Before we take a look at the main function, as you can see, I didn't import array list and linked list because I already have my own file for these two, so that I'm not using method from standard library. So let's move to the main interface. For the main interface, you have 6 options. You can add tasks, remove tasks, search tasks, display all tasks, and calculate all the values. and you can exit. So let's take a look at the third case, which is searching task. As you can see, user will need to put their task ID in order to search, and if the search is found, then it will print out the details of the task, and if it's not, it will say that task not found. Let's take a look at the output. As you can see, here is my task, list of the tasks, and I'm trying to search for task 1, and it's printed out successfully. And I'm trying to do the same thing as well to find the task for 3, and it's printed out also. So let's move on to case 4, which is the one that we're doing right here, printing out all the tasks. Just go through the loop, and if the task list is empty, it will say no task available. For the case 5, we are going to find the sum, count, min and max. And for the min and max, we have declared it by putting a minimum and maximum approximate value, and through the loop it will find the sum and min and max also. And outside here, we will try to find the average. Let's take a look at the output. As you can see, here's the total estimated, average, minimum and maximum estimated hours. And let's try to go to case 2. Case 2 which is a situation where it will remove the task. You can remove the task at the front, task at the back, and task at certain index. And it's basically the same as the case 1. It will move data from linked list to array list. And let's try to remove some tasks. Let's take a look at the output, where I'm gonna remove all the data. So first of all, I'm gonna choose 2. It will ask whether you want to remove the task. I want to remove the task at the front. So when I try to print it back, the first task is already gone. And let's say I want to remove the data at specified index, and I want to remove the index at this 1, which is the second index. You can see that based on here, the second index is actually ID2, because since the ID1 is deleted already, so when we try to print out the data, there's only ID3 remain. That's all from me. Thank you.